Okay. So previously we studied two processes. No? First one is we have studied about concentration of ore. Okay, ma? Then we have studied about reduction of ore. No? So what is meant by concentration? Concentration means removing the impurity. This is called as concentration. No? Reduction means converting ore into metal. This process is called as reduction. So these two processes we have studied previously. Okay. Now we are studying the third process, which is called as refining of this metal, which is removed after reduction. Clear? No? So therefore, what is meant by refining? Converting 95 to 97% pure metal into almost 100% pure material is called as refining. So how many methods of refining are there? Ma? First one is called as liquefaction, or you can call it as liquefaction. Second one is distillation. Okay, ma? Third one is called as electrolytic refining. Okay, ma? Fourth one is called as zone refining. And fifth one is called as chromatography. Are you able to understand, ma? And one more method is there, which is called as vapor phase refining. Okay. So these are the different methods which we use for refine a metal. Okay, ma? So let us study about each of them in detail. So what is the first method, ma? First method is called as liquefaction, or you can call it as liquefaction also. So this method is used in which condition? For metals whose boiling point is less than impurities. Okay, ma? Are you able to understand? So liquefaction we use in which method, ma? We use for that method where boiling point of the metals is less than boiling point of the impurities. So impurities have more boiling point when compared to metals. Okay. And what are the metals by which we can purify? We can purify lead. Okay, ma? We can purify tin, and we can purify bismuth. So these examples are very, very, very important, ma. You are supposed to remember these examples. Clear, no? So tin, lead, bismuth, these are the three metals by which we can use this process of liquefaction. Okay. Now we have to draw a beautiful diagram. See, ma. See here. So this is a heat furnace, ma, and it is arranged by certain angle here. Okay, ma. So this heat furnace will supply very huge amount of heat energy. Okay, and whatever metal I want to purify, that metal I will pour into this container. Okay, ma. So as it passes down, can you say what happens? As it passes down, can you say what happens, ma? So we are maintaining how much temperature? We are maintaining that temperature by which these metals can melt. But impurities will not melt. That is what happens, no? So in this process, what happens is, here, a layer of impurities will be formed like this. Okay, ma? What is this? This is layer of impurities. And what about the remaining metal? Remaining metal can be collected in a container. So metals comes and deposits here in the form of molten form. Molten form means if it melts, then only it flows down. No? Are you able to understand what is happening? So this is metal. How much pure this metal is? 95 to 97% it is pure. So if I place it on a heat furnace, it starts melting. And what is the condition we have studied? Boiling point is less than boiling point of impurities. So metal will melt. Impurities will not melt. So they will get settled on the surface of this slope. Okay, and remaining metal, which is converted into liquid form, it is collected in the container. Very simple process. So this process is called as liquefaction process. Are you able to understand? Diagram may be different in different textbooks, but the basic working is this much only. Okay, and the second process which we are studying is distillation. Completed this one? Okay, ma. Second method is distillation. Now, no need of explaining all this, no, ma. This is collected metal, collected pure metal. Okay, and on the slope, on the slope, impurities are deposited. Impurities are deposited. Okay? So just these are the 2 points which you should remember. Clear now? Then the second method is called as distillation method. And here we have, you should have studied in lower classes. There are many types of distillation. There is one method called fractional distillation also. Okay? So all those methods we are not studying. Just we will study what is the overall view of the process of distillation. So here also, the boiling point of metal, okay ma? Boiling point of metal is less than boiling point of impurity. Same concept here also. Okay? So when compared to impurity, the boiling point of the metal will be lesser. Okay? So here what we do, and what are the metals which can be purified in this process ma? Metals are mercury, cadmium and zinc. These are the metals which can be purified by this process, and these examples are very important. Clear nama? Mercury, cadmium, zinc. These are the metals which can be purified or refined by using distillation process. Okay? Now we have to draw one more beautiful diagram. రేపటి నుంచి నేను ఆర్గానిక్ టీచ్ చేస్తారు, ఒక డయాగ్రామ్ కూడా ఉండదు అందులో. అయితే ఉత్త బ్రిడ్జులు ఉంటాయి. Okay, see ma. So in this distillation process, we use this container in which metal is present ma. Impure metal is present. Okay. Now just I start heating this impure metal. And what is the heat I have to supply? Heat supplied is just enough to melt the metal itself, so that it is converted into vapor form. Clear nama? And the impurities which are present, they remain in the container itself. They are not evaporated. Are you able to understand? Yen rastam ikkada? Boiling point of metal should be less than boiling point of impurities. So we supply only that temperature where metal will melt, but impurities does not melt. So therefore, these impurities, this metal, it is converted into liquid form, vapor form, and here it is collected in a container. Okay? Very simple diagram. So this is the process of, second process, which is called as distillation. Understood nama? Then we study about the third process, which is called as electrolytic refining. So now I hope you can understand all this nama. What is this one? This is pure metal. Okay? Remaining impurities are settled at the bottom of this container. Okay? Third one which we study is electrolytic refining. So the process of electrolysis you should have studied many times in your lower classes. Process of electrolysis. Same process we will study here also. So we take an electrolytic apparatus and we insert one impure metal. For example, here what are the metals which can be refined? Copper, zinc. These are the two metals which can be refined by using electrolytic refining. Examples are very important. Clear? So copper and zinc, two metals which can be refined by this process of electrolytic refining. Okay? Now here what we do, we take this metal rod which is impure copper. Now I am purifying copper here. Impure copper. Impure copper means 95 to 97% pure copper. Clear no? Then here I will take another electrode which is made up of pure copper. Okay? And in this electrolytic vessel, I will place CuSO4 solution. What is the solution I use CuSO4, copper sulfate solution will be taken. Are you able to understand? And this side it is connected to positive terminal of the battery, and the second electrode it is converted, it is connected into negative terminal of the battery. The electrode which is connected to positive side, it is called as anode, and the side in the electrode which is connected to negative side, it is called as cathode. So this is anode. Okay, and this one is cathode. Are you able to understand? Then in this process, what happens? In this process, the metal, the copper metal which is present in this anode, it continuously melts and it goes and mixes with the liquid. Okay, ma? So metal, which metal? Copper metal goes and continuously deposits into the solution. Are you able to understand? So what happens to the size of this anode, ma? When size continuously decreases, no? When metal melts, what happens to the size of the cathode? It continuously decreases. And in that process, whatever impurities they are present, they are deposited at the bottom of this cathode, bottom of this anode. Okay, ma? And here impurities will be deposited. Okay? And these impurities, we can call them as anode mud. Okay, ma? What is the name given to these impurities, ma? Name given to the impurities is anode mud. So here what are the different types of impurities we can find? We can find gold also, we can find mercury also, we can find platinum also, we can find selenium also, we can find polonium also, we can find strontium also. So these are the examples again which you are supposed to remember. Are you able to understand, ma? Yes, see, selenium. So these are the impurities which are present in this impure anode, and they will be deposited continuously as anode mud inside the same anode. Are you able to understand? And the copper which is present in this solution, it goes and continuously deposits on the cathode. Are you able to understand? This is the same process which you have studied in previous classes, no ma? Okay. Size of anode continuously decreases and size of anode cathode continuously increases. Okay. So here metal is melted into the solution, and the metal which is present in the solution, that goes and continuously deposits over the cathode. Okay. So therefore what happens is size of anode continuously decreases. Okay, ma? And what happens to the size of cathode, ma? Size of cathode continuously increases. Okay. So this is what happens in the case of electrolytic refining. And these are the metals which will be deposited as anode mud inside this cathode, inside this anode. Is it clear? So this is the third process which is called as the process of electrolytic refining. Okay, ma? And we study the fourth process which is called as zone refining. Fourth process is what? Fourth process is called as zone refining. Okay. And this is a very modern method of refining. Very modern method of refining particular metal. Okay. So here what are the metals we can refine by using this zone refining? We can refine semiconductors. Okay, ma? Or you can call them as metalloids. Okay. So these metalloids or semiconductors can be refined by this process which is called as zone refining. Examples: beryllium, silicon, germanium, gallium, indium, like these kinds of metals. All these, they are semiconductors only. No? So these metals can be refined by using this process which is called as zone refining. Let us see how this works out, ma. See, what we do is we make a metal, we make a rod which is made up of impure semiconductor. Come on. Let us consider it is germanium, for example. Come on. We are taking a metal of semiconductor which is called as germanium. Are you able to understand? Then what we do is, surrounding this rod, we place a heating material. We place a heater. Are you able to understand? So this kind of heater we will place around one cross section of this, what you call this impure germanium rod. Understood, no? So because of this heater, here the metal starts melting, no? Here the metal starts melting. That is what happens, no? Then what I do is, I move this heater slowly onto the right side. Okay, ma? Here what I can write, heater is moved to other end of rod. Other end of rod. Okay. So I start moving this rod, this heater, to the other end of the rod. In this process, what happens is, whatever impurities which are present here, okay, ma? These impurities also, they start traveling along with this heater. And in this condition, in the case of zone refining, write one important point. In the case of zone refining, the point is that boiling point of impurities is less than boiling point of metal. Understood, Amma? So here, which one is which can be liquefied more easily? Impurities are liquefied more easily. Are you able to understand? So here, germanium doesn't melt. Impurities which are present in the germanium, they start melting. Are you able to understand? So if I take this coil, heating coil, to other end of this germanium metal, then what happens is, impurities also move along with heater. Okay, ma? So there is some arrangement which is made by which as the heater starts moving, these impurities also, they start moving to the other end of this rod. Are you able to understand? So finally what happens is, all the impurities, they get settled at one end of the germanium rod. Okay, ma? So all the impurities, they come and get settled here. Are you able to understand? And what is this one? This is crystallized pure germanium. Okay, ma? This is called as very pure germanium which we got. And what are these? These are the impurities which are deposited at other end of the rod. And they are cut like this, ma, and they are removed from the rod. Are you able to understand? They are cut and removed. Symbol chudandi enta beautiful ga chesna. Clear ba? So this process is called as zone refining. Are you able to understand? So now we will study the next process which is called as, I don't think this one is important, ma. We are discussing this one, vapor phase refining. Okay, completed, no? KADAPA. Okay, ma? So the next type of refining which we are studying is vapor phase refining. So by using vapor phase refining, which are the metals which we can refine? Nickel, zirconium, titanium. These are the three metals which can be refined by using this process. Are you able to understand, ma? Arshia kaise hota happy se hi. Ab tak dal thera. Okay, ma? So here in vapor phase refining we have two methods. Now one is called as Mons refining, and second one is called as Van Arkel refining. So these are the two methods by which we can refine these metals. Okay, ma? So by Mons refining we refine nickel, ma, and by using Van Arkel method we refine zirconium and titanium. Understood, no? So these examples also can be asked in the examination. So first of all we will study, let us see what is the basic concept of this vapor phase refining, ma. So here what happens is, here metal is converted into volatile compound. Okay, ma? And again decomposed, and again it is decomposed, or you can call it as heated, to get pure metal. Okay, ma? So this is the technology which we are using in this last type of refining, which is called as vapor phase refining. So what is happening here? Metal is converted into volatile compound. What is meant by volatile compound? Which can evaporate very easily is called as volatile compound. Then after converting into that volatile compound, we again start heating that one, so that I get a pure metal again from this volatile compound. Understood, no? So first of all we will define the first method, which is called as Mons method. So in this Mons method, which is the metal we refine, ma? It is nickel. Okay, ma? So nickel plus 4CO, it converts into NiCO4. This is what happens. And what is this one? This is volatile, unstable compound. Okay, ma? So the material, the compound which we got is, it is a volatile compound and it is very unstable also. Unstable means what? It again disintegrates into nickel and carbon monoxide very easily. That is called as very unstable compound. And here the temperature which we have to supply is, okay, ma? 350 Kelvin. So this is the temperature which we have to use. Are you able to understand? Let us see, ma, whether it is Kelvin or degree Celsius, I forgot. Kelvin only. Okay, no? So then this NiCO4, again it is heated up to 470 Kelvin to convert into nickel plus carbon 4CO. Okay, ma? And along with this, along with carbon monoxide, oxygen and nitrogen are also evolved, are also released. Okay, ma? Which were the impurities. Okay, so are you able to understand what is happening, ma? So this volatile unstable compound, again we are heating this one. At what temperature? At a temperature of 470 Kelvin. Temperatures also you are supposed to by heart them. Okay, ma? Then it disintegrates into nickel and again carbon monoxide. But in this process, the nickel which is obtained, it is very pure. This is a very pure nickel. And this was an impure nickel. Are you able to understand? And in the same process, the other impurities like oxygen and nitrogen, they are also released. So this is another point which you should remember. In the case of Van Arkel method, the remaining impurities are what? One is oxygen and the second one is nitrogen. These impurities also, they are released from the metal. Are you able to understand? And the next method which we study is Van Arkel method. Okay, ma? So, Van Arkel method. So here what are the impurities which we will purify, ma? One is zirconium and the second one is titanium. So these are the two metals which we purify by using this second method. Okay. So here what happens here, zirconium plus iodine, they react into ZnI4. Are you able to understand, ma? And this compound, it is volatile and highly unstable. Okay, ma? And it is performed at a temperature of 870 Kelvin. So these temperatures and what are the compounds we are using and which are the reducing agents. So see them very, very, very carefully. Clear? So here the compound which we are using is carbon monoxide. And here we are using iodine. Carbon monoxide in Mond's process, iodine in Van Arkel's process. Is it clear? Okay. Then I take this non-volatile and unstable compound. And again I start heating this one at a temperature of 2274 degree Kelvin. Clear, Nama? Then again it integrates into zirconium and 2I2. And in this process, the zirconium which is obtained is very pure. Is it clear? Now the same concept you can write with the titanium also. Same reaction. Same reaction you can write with titanium also. How can I write? Again same. So titanium plus 2I2 at a temperature of 500 Kelvin. Okay, ma? It converts into TiI4. Again which is volatile and highly unstable. Clear, no? So this volatile and unstable compound, again we are heating this one. Okay. So TiI4, when it is heated at this is 500 Nama, 1700 Kelvin, then again it disintegrates into titanium plus 2I2 and other impurities like oxygen and nitrogen are released. Okay, ma? So here also you have to write this concept. Here also O2 and N2 which are acting or impurities are released. Are you able to understand? So this is the total refining process which is present in our syllabus. Are you able to understand, ma?